Hello everyone! In this video we're going to be talking about MATLAB's built-in debugging mode. So debugging is a very important concept in computer programming. It's basically the way you go about correcting mistakes in your code. So as you all have probably noticed so far in this class is sometimes you write your code and you run it and it doesn't work and you don't know why. That's super common. A lot of time goes into figuring out, well, where is the code going wrong? And kind of these built-in debugging modes offer a way for kind of checking and making sure that everything is going how you expect. So what I'm going to do for this video is I'm going to use the bisect code that we have from our previous video. So I'm going to open it. And we can see here, yep, here's the code. The only difference is I've added, so this line 19, I've also included it at line 7, and that's just because we're going to be putting what's called a breakpoint here. So I'll show you what that is in a minute. It's basically just a place where we're going to have the code stop. So I wanted to stop here so that we can enter the while loop together, but I'll show you all of that in a moment. But before we do that, what I want you to do is go to this kind of triangle in the upper right corner, at least it is in my screen. And then I'm going to click Doc Editor. And what this does is it puts kind of where we edit our bisect code into the command window. And a very important thing that we're going to be able to do is the workspace variables are going to be shown for the bisect function. So as we're tracing through the function, we're going to be able to see how are the variables updated. So now let's start by putting a breakpoint. So if I hover over a line of code in the editor, so let me make sure I'm here, you can see it gets highlighted with this red box. So I'm going to click line 7 in my code, and you can see here I get a little pop-up that says execution will be paused at line 7. So let me show you what's going to happen. So I'm going to say, let's run the bisect code. I'm going to do it with the example of x squared minus 2. Now here's an example of how you can have a function handle directly as an input. I don't need to define it as a function f beforehand. I can just put it directly like that. And remember, we said our x negative, we could pick 0 because 0 squared minus 2 is negative. Our x positive could be 2. And then let's have an error of 0.01. I'm going to press enter to run. Now notice in the editor for the bisect code, I get this green arrow pointing to what line of code I'm at. So right now we've entered the function and we can see the error is defined, f is defined, x negative and x positive. Now what's going to happen is I have a couple options. I could press continue, that's going to run the rest of the code. But more common for us is we're going to be pressing this step button, which runs the next line. So I'm going to press step. Now notice x0 has been defined as x negative. So x negative and x0 are the same. Now what's going to happen is we're going to enter the while loop, so you can see it's highlighted here. And it's going to check, is the absolute value of x negative minus x positive greater than or equal to the error term? So x negative is 0. 0 minus 2, an absolute value is 2. That's certainly greater than 0.01. So I'm going to step again. And now we can see, okay, x bisect is going to be defined as x negative plus x positive divided by 2. So it's going to be 0 plus 2 divided by 2. That's going to be 1. So I'm going to click step. Now watch the workspace for x bisect. So there's x bisect, and we can see it's equal to 1. Next, so we're going to enter this, if we're going to check this if statement. So if f of x bisect is less than 0, so let's plug in 1 to our function. 1 squared minus 2 is negative. So then we're going to enter the if statement. So I'm going to click step, and you can see we enter the if statement. Then x negative is going to be equal to x bisect. So this is going to be x negative gets updated to 1. So we're going to press step. And you can see here x negative gets updated to 1. Now notice, because we entered the if statement, when we step again, it skips to the end. I can step again. And what's going to happen now is we're going to go back to the while loop and check the condition again. Or really that was kind of what was happening when we stepped from the end here. So let's see, our x negative is 1, our x positive is 2. 1 minus 2 in absolute value is still greater than our error term. Now we're going to define x bisect to be x negative plus x positive over 2. So x negative is 1, x positive is 2. 1 plus 2 is 3 over 2. So x bisect is going to be 1.5. So here we can see x bisect 1.5. Now we're going to check, is f of x bisect less than 0? So this is going to be 1.5 squared minus 2. And we can see, well, that's positive because now we've jumped to the else statement. So now x positive is going to be updated to x bisect. So this x positive should be updated to 1.5. So we can see here it got updated to 1.5. Then we're going to check the condition again. So difference between x negative and x positive is 0.5. That's still greater than our error term. So we enter again, and I'm going to quickly step through the program. You could do it on your own slower if you'd like. But let's see. You can notice x negative and x positive are getting closer and closer together. And you can see here that the difference between x negative and x positive is less than the error 0.01. So now we're going to set x0 to x negative. So x negative is 1.4141, and that's going to be what x0 gets set to. So now notice I'm at the end of the program. I'm going to step, and I leave the function. And all that's left over is the answer 1.4141. So I hope that was helpful and kind of shows you how you can trace through code using MATLAB's built-in debugging mode. To remove a breakpoint, you just click on it again. So thank you for watching, and I will see you in the next video.